the Always Believe house. Today we're going to start direct variation. And it is going to be F-U-N, fun. This is basically Algebra 1's proportions, okay? So in 6th, 7th, and 8th grade, you did proportions. We're going to do proportions today, but it's called direct variation, and you write it differently than you would a proportion. So let's get rocking and rolling with direct variation. A magical whiteboard appears, and we will get going on this pretty cool lesson. Okay, so let's go. Direct variation, I'll write this down, is going to be y. Let's put y equals kx, okay? That's the form you're going to use for direct variation. Okay, now then, if you have y and x, okay, because this makes a table up, right? I'm going to just start you off here. Y'all write this down. Y over x equals y over x. Y'all with me? And then I'm going to multiply both sides of the equation by x, and I would get y equals y over x times x. This y over x right here is your k. So do y'all see how I'm going from this proportion to this? Okay, we'll get into this more. This may be a little bit confusing, but basically your slope in a line without a y-intercept is going to be direct variation. So let's get rocking and rolling. All direct variation formulas fit the formula y equal mx or y equal kx. The variable m is called the slope or rate of change. The variable k is called the constant of proportionality. Basically, this is a line that goes to the origin. A line that goes to the origin is proportional, and you studied this in junior high. And I know y'all remember that you had all those graphs and you had to figure out which ones were proportional. The lines that went through the origin were proportional, and they did not have a y-intercept, don't they? So in this problem right here, our y-intercept would be plus 0. We wouldn't write the plus 0, so it would just be y equal mx or y equal kx. The k is called the constant of proportionality. And you did this in junior high, just figuring out which lines were proportional or not. So I'm going to zoom in over here. In the direct variation function, y equal 3x, what is the constant of proportionality? It's the number 3, right? Which is the slope or the rate of change. In the direct variation formula, y equal 2 over 3x, what is the rate of change? It's 2 over 3, right? In the direct variation formula, 6y equals 24x. Let's write this down first. And we need to solve for y. We would get y equal 4x. The 4 would be our slope, wouldn't it? And continuing on. It's stuck. Okay, continuing on. Y equal 8.25x. Okay, so write this down. And then if I'm going to plug in 7 for x, I would get 8.25 times 7. So y would be 56 plus $1.75. I believe 57 and 75 hundredths, or $57.75. Okay. And then on letter E, I'm going to write down y equals 5x. This is going to be a big deal. This is a big difference than what you did in junior high, because in junior high you made a proportion. Now you're going to make a direct variation equation, and you're either going to replace the y or the x with a number. So you're not going to make a proportion like you did in junior high. Now then, we're going to replace the y with 20, divide by 5, and we would get x equals 4. Fun stuff. You'll see this when we start doing word problems with it. Instead of making a proportion, we're going to make a formula that looks like this, and then get the answer. Okay. If you graph a direct variation function, the y-intercept, it has to go through the origin. It must be 0. You did this in junior high. Also, the slope must be positive or negative, not 0, not undefined. It can't be horizontal or vertical. It has to slant up or down. And it has to go through the origin, which means the y-intercept will be 0 and you'll have just y equal mx or y equal kx. And let's keep continuing going. Okay, does this have direct variation? Circle the origin and write yes. You could write the line goes through the origin, right? In a table of values, the 0 will be 0 on it. So if you have a table of values and 0, 0 is in the table of values, the table will have direct variation. Let's go to letter B. Yes, the y-intercept is 0. Okay, if it has a number over here, it does not have direct variation. It can't have a y-intercept. Let's go to C. Does it go through the origin? Yes. Letter D. Does this go through the origin? No. It does not have direct variation, does it? Letter E. Does it go through the origin? No. And it also has a slope of what? Undefined, right? It cannot be vertical or horizontal and have direct variation. It has to slant, it has to have a slope, and it must go through the origin. Okay? Same thing you did last year, but you were using proportional instead of direct variation. Okay? If a relationship is direct variation, it means that the two quantities, x and y, are directly proportional. So write this down. You would have y over x equals y over x, which is what we put at the top of the page. Basically, you're putting your y term over your x term, and you're getting your constant of variation. Every y divided by x in the table will be equal. You did that in junior high to prove that it was proportional. Okay, in other words, you can always write y equal blank x with a number, not 0, in the box. So this number is going to be your slope in it, or y over x, the change in y or the change in x. For each situation below, first decides if it represents a direct variation function or not. Okay, so what we're going to do is figure out if these have direct variation. Okay, so we know our x and we know our y. Now then, this is the way I would like you to do this because it's going to make sense from what you did in junior high. Put y over x. And I'm going to zoom into just this table. Now then, the y, let's put cost, or I'm going to put dollar over tickets, right? It's important that you're putting the labels down here when you do this. Now then, we're going to put y over x. So my first y over x will be 16.5 over 2. My second one will be 41.25 over 5. And my last one will be 8.25 over 1. You might remember doing this in junior high. Now then, if you have a calculator, punch each of those into the calculator. If you punch each of them into the calculator, this is going to be 8.25. If you punch 41 and 25 hundredths divided by 5, you will get 8 and 25 hundredths. And that 8 and 25 hundredths divided by 1 will also be 8 and 25 hundredths. So these are all the same. Check, it has direct what? It has direct variation. Now then, this 8.25 is y over x, and it's equal to our k in it. So this equation would be y equals 8.25 times x, where x is the number of tickets and y is the total amount of money. So in a word problem, if I wanted to know how much money 13 tickets would cost, I would replace the x with 13. If I wanted to know how many tickets I could buy for 80 bucks, I would replace the y with 80 and solve for x. So you're going to plug into the y or the x instead of making a proportion, like you did in junior high. Now we're going to use a direct variation equation. And something else on this table from junior high, if you were to cross multiply, the cross products would equal every single time. If I multiplied these two, I would get 81.5. And if I were to multiply these two, I would get 81.5. Okay, or actually 82.5. Sorry about that. If I were to multiply this times this, I would get 16.5, and I would get 16.5, wouldn't I? Any set of cross products are equal because the table has direct variation and it is proportional. Direct variation and proportional is the same thing. But you're not going to make a proportion here. You're going to make a y equal kx equation. which you will get when we get to the word problems later. Now then, let's go to B. This is our x, this is our y. So I'll write down y over x. We're going to write down, let's put the max over the number of weeks. Okay, so we're going to put the maximum weight we can lift over the number of weeks. We have 3 rows, 3 fractions. So our first fraction, y over x, will be 130 over 3. Then 150 over 5. Then 180 divided by 8. Now then, punch these into the calculator. If you do 130 divided by 3, you get 43.3 and the 3 repeats. 150 divided by 5 is 30. Are these the same? They are not the same, are they? So, this table does not have direct variation. You started this in 6th grade when you were given a table in 6th grade and you had to figure out if it was proportional. There was a lot of ways to do it. One way is you can divide y by x every time and solve they equal. The other way is to cross multiply. 3 times 150 is 450 and 5 times 130 is 650. These are not equal, are they? Since they're not equal, it's not proportional and it does not have direct variation. You would not be able to write a y equal kx equation. Oh, a lot of information in here. Basically, you are learning that a proportion is now called direct variation, and instead of putting y over x equals y over x, we're going to write it as y equal kx. Oh, now then, let's turn the page. Now then, we're going to solve these with direct variation, okay? Suppose we know that a dance ticket costs $6. How much would it cost for 4 tickets? In junior high, I'm just going to show you this one time. In junior high, you would have put dollars over tickets, and then you would have put 6 over 1 equals, and I would want to know how many 4 would cost. I would do, and let's make this, let's put this as D for dollars. Okay, so I'm going to do 1 times D equals 6 times 4, and I would get the dollars equals 24 whatnot. That's how you did this in junior high. Now we're going to set up a direct variation equation. So we're going to write down y equals kx, and I know that 1 dance ticket costs $6. So I'm going to have y equals 6x, and then my number of tickets is forwarded. I'm going to replace this x with 4, and I'm going to get the same thing, aren't I? Okay, so on the left side, this is what you did in junior high. Now you're going to set up a kx equation, and you're going to get the same answer. Let's go to letter B. How much would it cost for 10 tickets? Y equals 6 times x, y equals 6 times 10, and you would get y equals 60, wouldn't you? So now we're not making a proportion, we're either going to replace the y or the x. The y is the total amount of money, the x is the number of tickets. Let's go over here. Describe in words how to calculate the cost of any number of tickets. Multiply by 6, right? Which is the constant of proportionality. Okay. Oh. So basically you're multiplying the number of tickets by 6. Let's go to D. X is equal to the number of tickets and y is the cost of those tickets. Write the equation of this in direct variation. You would write y equals 6x. That would be your constant of variation, wouldn't it? Okay. Where the 6 would be $6 per 1 ticket. Okay. $6 per 1 ticket. Now then, let's go to the next set. Use the equation y equal mx, which has 3 variables, to answer the following equation. Okay, so this is where we're going to get into the meat of this. If y equals 35 and x is equal to 5, your constant of proportionality is always y over x. Always, always. It's the y over the x. The y over the x. Okay, so on this problem, we're going to put 35 over 5, and we're going to get 7, right? Now then, write down y equals 7x, and then we want to know what y is when x is 12. They're either going to tell us what x is or y is. If they give us the y, we'll divide by 7. If they give us the x, we'll multiply by 7. On this problem, they're giving us the x is 12, so y is going to end up to be 84. Okay, if they gave us the y, we would end up dividing by 7 to isolate the x. You would have to move the 7 over, wouldn't you? Okay, now let's go to the next one. In a direct variation function, y equals 30, x equals 4. Write down y over x and put y over x to make a fraction. You would get 30 over 4, wouldn't you? Most of the time, we will leave this as a fraction and not a decimal unless it has money. So if you punch 30 divided by 4 on your calculator, you would get 15 over 2. Okay? Or 7.5. Let's go down. Let's make this 7.5. Okay, this will be a little bit simpler on this time, okay? Now then, let's go down. Write down y equals 7.5x. And now we know y is 65. We want to find x. So we're going to replace y with 65, aren't we? Now then, we're going to divide both sides by 7.5. And I do not know what that's going to equal to. I've got to pull up a calculator. Let me do that real quick. The calculator, 65 divided by 7.5. I did not punch the 7. 65 divided by 7.5. I cannot do that in my brain. 8 2/3, okay? So we're going to get 8.7 or 8.6 with a bar or 8 2/3, okay? That's kind of a bad problem because it didn't divide out, okay? So basically, you're going to find y over x. You're going to write y equal kx. You're going to replace y with something or x with something, okay? Let's go to the next one. In a direct variation, the constant of proportionality is 3. That means y over x is equal to 3. So your equation is y equal 3x. What is y when x is negative 5? Y equals 3 times negative 5. Y would be negative 15. Ho, 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 ho. Piece of cake. This is not rocket science, people. It's pretty simple stuff. Let's go to letter D. In a direct variation, y equals 18. X is equal to 3. Write down y over x. You're going to put 18 over 3, and you're going to get 6. That's called the constant of proportionality, or the slope, right? What is the equation of the direct variation equation? It's going to be y equals 6x. We're either going to replace x with something or y with something and solve for the other number. Piece of cake, piece of cake. Let's go to here. A direct variation line passes through the point 3, negative, or 3, 12. This is my x, this is my y. So write down y over x, and my y is 12, my x is 3. That simplifies to 4, doesn't it? Always put y over x to get that k term. So if I were to write down y equals kx, I would get y equals 4x, wouldn't I? Ho, 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 ho. Piece of cake. And lastly, to finish up these notes, we're going to go to here. Y equal mx plus b, where m is the slope, b is the y-intercept. Given the equation y equal negative 2 over 3x plus 5, we're going to do the following stuff. So let's write down y equals negative 2 over 3x plus 5. First off, this would not have direct variation, would it? Because it has the 5, right? Since that 5's there, it will not go through the origin. So our slope is negative 2 over 3, which means I'm going to go down 2, right, 3, and my y-intercept is 5 in it. So I'm going to graph the equation. Remember, I like calling the y-intercept the starting number because that's what you start with when you graph it. You start graphing with the starting number, which is your y-intercept. So our y-intercept's 5. We're going to go up 5 and draw a dot. Now then, I can zoom in on this. My slope is negative 2 over 3, right? So from the starting number or the y-intercept, you start with the starting number, the y-intercept, draw a dot, then you do what the slope tells you to do. Our slope is negative 2 over 3. So I'm going to go down 2, right 3, and draw another dot. And I'm going to repeat that process till I go off the graph. Down 2 over 3, down 2 over 3, down 2 over, I didn't go over 3. And I can't go down 2 over 3 again, can I? Now then I'm going to go backwards and go up to left 3. Up to left 3, up to left 3, and I got my dots. Notice that these dots have a constant rate of change, don't they? These dots have a constant rate of change, and our line would look something like this, would it? Okay? That's what the line would look like. Y'all got to be able to graph a line. You start with the y-intercept, and you go up or down to the right. Would this line have direct variation? It would not, because it does not go through the origin. That's something you learned in 8th grade. I hope you've had a great time today. Make sure you go over this again if you have any questions. Remember, we're not making a proportion now. What you'll see in the word problems we're going to do, we're making a y equal kx equation, which means you have a proportion in Algebra 1. Have an amazing, amazing day. Remember, you are awesome. You are made to do wonderful things. And again, you are awesome.